Welcome everyone. This is the Future Scanning Energy Group project presented by Lydia Shaneberger and myself, James Fowles. There are many aspects of energy. The portion of energy we are discussing is defined as the power derived from the utilization of physical or chemical resources, especially to provide light and heat to work machines. In 2017, the U.S. consumed nearly 100 quadrillion BTUs, which are British thermal units of energy. This pie chart shows that the largest percentage of that, 37%, comes from petroleum, a non-renewable resource. The renewable energy consumption is only around 11%. With the vast majority of energy consumption coming from fossil fuels like coal, petroleum, and natural gas, government-funded research is focused on renewable energies. Some examples of renewable energies are geothermal, which is the thermal energy generated and stored in the earth. Then there's wind, solar, bioenergy, hydropower, tidal, which is a conversion of the energy from the tides into useful forms of electricity. And then there's hydrogen and green power, just to name a few. Steve Chu, who was a former and longest-serving U.S. Secretary of Energy, says that the technologies that offer the greatest hope or greatest potential for sustainable energy are solar and bioenergy. These will be the two renewable energies that we will be discussing. So what is bioenergy? Bioenergy is energy derived from biological sources, such as biomass. Biomass is defined as any organic material that may be turned into fuel. These fuels are referred to as biofuels. The following image depicts the relationship between biomass, biofuels, and bioenergy. Bioenergy has many positive attributes. In most cases, it is carbon neutral and stored with very little energy loss. It also provides a useful way to dispose of waste and helps in land management practices. Bioenergy is a viable solution to help combat the pressures of our natural resources, especially considering the ever-increasing global energy demand. Bioenergy has been around for centuries, so why is it still important today? What future does it have? With the continual advances in biofuel science, the cost for production is becoming more competitive with fossil fuels, and the recent ability to use it in large commercial transportation vehicles reduces emissions from a major pollutant. Also, new technologies in bioenergy are still being discovered, such as converting algae into crude oil. We will now take a look at some examples. In biofuel science, the replacement of expensive enzymes with a much less expensive and readily available acid catalyst increases the ease of the fuel's sugar recovery. The sugars are what is extracted to produce the oil. Another example pertains to the use of biofuels in commercial vehicles. The first commercial flight using 30% biofuel mixture was set to take flight this year. The following video demonstrates the technology of converting algae to crude oil.
Making fuel from algae sounds like science fiction, but that's the goal at Pacific Northwest National Laboratory. Engineers have created a new way to turn the green goo into energy as part of an effort to reduce use of traditional fuels like oil, which contribute to climate change.
Well, solid biomass is not something that you can put into a car or into an engine. We need to change it chemically and physically. Our recent publication of our results describes our work in a continuous flow reactor system. It's an actual processing design that could be scaled up to large scale for actual production of real fuels.
The process subjects algae to very high pressure and temperature, the same conditions within the Earth that transformed algae to oil millions of years ago. It's a seamless process. Engineers put algae into the reactor for less than an hour, and out comes crude oil, water, and some usable byproducts.
This is the algae feedstock that we use in our process. It is about 80% water at this point in time. Once we put the algae through our processing system, it's converted into this type of light bio-crude oil. Final step of the process is then to convert the bio-crude into a finished hydrocarbon product. That's what is in this jar. It's a mixture of gasoline and diesel range hydrocarbon materials.
We can make fuel from algae today, but it's not easy or cheap. This research simplifies the process dramatically, a key step toward lowering the cost of algae fuel.
The future of biofuel is supported by the U.S. Department of Energy. In September of this year, $80 million has been allocated to support research and development. This is a further breakdown of that $80 million. Up to $28 million going to bioenergy engineering. Up to $15 million going to carbon utilization in algal systems. $22 million going to process development for advanced biofuels and biopower, and the remaining $15 million to affordable and sustainable energy. In conclusion, bioenergy as a renewable energy has the potential to not only reduce the use of fossil fuels, but it can also reduce our reliance on foreign imports. The biofuel science is continually improving the efficiencies of biomass to biofuel conversions. New innovations in algae to crude oil transformation has provided new opportunities and technologies to replace petroleum-based products. Bioenergy is not a standalone solution for the future of energy, rather part of a team of renewable energies that need to become more efficient to offset the increase in demand for energy. This must be done in a way not to upset the balance of resources from our plants and animals that we must sustain to continue to feed and clothe our growing population. At this time, I will hand you over to Lydia, who will discuss another important renewable resource.
Hi everyone, my name is Lydia and I'll be going over with you the part of our presentation of solar energy. Solar is the Latin word for sun, and it's a source of energy that can be used to heat, cool, and light our homes and businesses, cities, and countries. That's because more energy from the sun falls on the earth in 1 hour, just 1 hour, than is used by everyone in the world in 1 year. We're going to talk about the variety of technologies that convert sunlight to usable energy for buildings and homes. So this is a little diagram about how the most basic solar energy works, with panels and it going to a control device and then a breaker box, and then you can plug anything you like into it, power, as far as power, like lamps, refrigerators, heaters, of course, hot water heaters, things like that as well. So this is the breakdown of the Earth's energy budget, basically what the Earth takes in from the sun, which is 100% solar energy, and what is absorbed by the land and oceans, over half of that, which is pretty amazing. What's absorbed by the atmosphere, the clouds, and also what comes in water vapor back up to space. So, type of solar energy, this is called solar photovoltaic energy. This is basically called PV, I'll just call it that, cells by scientists that convert sunlight directly into electricity. PV gets its name from the process of converting light to electricity, which is called the PV for photons and voltage. It was discovered in 1954, wasn't too long ago, when scientists at Bell Telephone discovered that silicon, an element found in sand, created an electric charge when it was exposed to sunlight. So Then solar cells were used to power calculators, watches, even satellites, things like that. This is a little diagram about how the solar energy works with this type of energy. It basically creates a current because of the materials in the middle and the electrode charge on the front and the back, and also the sunlight coming through. Concentrating solar power. This is basically when fossil fuels use a heat source to boil water. The steam from the boiling water spins a large turbine, which drives a generator to produce electricity. And then, but a new generation of power plants with concentrating solar power systems use the sun as a heat source. The three main types of concentrating solar power systems are linear concentrator, dish engine, and power tower systems. This is an example of power tower systems, and it's mostly used in the desert. We don't really have anything in the mountains because we have a lot of forest here. Solar process heat. So this is when commercial and industrial buildings may use the same solar technologies that are used for residential buildings, but these non-residential buildings can also use solar energy technologies that would be impractical for a home. These technologies include ventilation, air preheating, solar process heating, and solar cooling. This type of process definitely has potential in the market. These two charts here they're by a company called Solarico. They show what percentage of the solar process heat is untapped to their clients, and kind of how between 2013 and 2016, how things have grown and shrunk a little bit in the textile and leather industry, but also have grown in the oil and gas industry when there was nothing in 2013, and it grew just a little bit. Passive solar technology. This is actually something that I'm working on with building my tiny home. It takes advantage of a building site, climate, and materials to minimize energy use. A well-designed passive solar home first reduces heating and cooling loads through energy-efficient strategies and then meets those reduced loads in whole or part with solar energy. I'll kind of explain this in basic terms. This diagram here is basically the sun in the summer, which is of course different from the winter. The sun at the summer is higher, and it's also coming down in the lower point of the house. The winter sun is lower and coming through the house more. So here's a thermal mass wall, which actually captures the heat of the sun. They've got a couple skylights here. There's an openable skylight that acts as a vent, and there's also a breadbox water heater, which the sun will hit, and that allows them to heat their water. Solar water heating, I have seen some of these homes before. They were probably built around the 70s when people were just catching on to solar. They're pretty basic how they work. Basically, it is a catcher here, and the preheated water, you have, of course, your cold and hot, come down, but the pressure from the public system sends the unit so that the water can come down. You have an existing tank, and then there's your cold water and your hot water. The future of solar. So this has changed dramatically, especially in 1977 when solar was over $100 for each watt. The materials to build solar have cheapened, but the labor is still intensive. So this chart right here is basically our energy reserves. So look at this big yellow dot. That's solar. That's how much solar that we could be tapping into. Here's gas, petroleum, uranium, and there's coal. Wind is also up here. Wind is a good one too. So as you can see, we have not even started tapping into the solar reserves yet. 99% of new electricity generation capacity added in the U.S. in 2016 came from renewable energy sources. 64% of that was solar. Also, the average installed cost of a residential rooftop solar power system in the U.S. was $3.21. That came a long way from $100 in 1977. The future of solar research. So, there's a couple different projects going on. The first one is solar roadways. Scientists are exploring ways to actually line highways and roads with solar panels that would then be used to have large amounts of electricity to the grid, so they would send those to the grid. Solar roadways have already popped up in the Netherlands. It's really cool. There's a video on YouTube about it. Floating solar, that's a way to float solar. Since 70% of the Earth's surface is covered in water, there's actually projects set up in France, Japan, England, and other parts of the world, as well as California in the United States. So we're tapping into that one. Space-based solar. Scientists are resurrecting a technology that was first tested over 40 years ago, in which space-based satellites captured sunlight and then they converted it into microwave energy that is beamed back to Earth. That sounds really cool. India, China, and Japan are investing heavily in these technologies right now. So these are some of the pros and cons of solar technology. There's renewable, non-renewable, and of course, what both types of energy can be used for. This is kind of course, a Venn diagram. This is a little bit of a different diagram. So here, I'll show you how to read it. Like, emits greenhouse gas during generation. There's biofuels and biomass, and of course these two guys go down to these three categories. They're renewable, depends on water for turbines, and so on and so forth. There's oil and coal in there as well. So this guy actually did solar power for $2,000. I believe he's in the wilderness in Canada. He's off-grid. But it's a really cool video to watch and kind of look at how he engineered his solar panels and his design of his home. It's really cool if you're thinking about solar. So, solar technology here in the United States. I put two of these graphs up. Well, they're really colorful, but besides that, look at how much petroleum we are still depending on. And 0.5% of solar. But you remember that big yellow dot, right? We have tons of solar energy that's available to us, yet still over 1/3 is using petroleum. Here is another chart of the United States. It's basically, what they project, what they want as far as 100% transition to wind, water, and solar for all purposes: transportation, heating and cooling, electricity, industry, power. So this is kind of what they're projecting 2050 as the energy mix. So there's solar plants here. There's our residential rooftops. Here's our onshore wind, offshore wind. And there's the government commercial solar on your rooftop. Geothermal energies in there, hydroelectric, tidal turbine 0%. I believe tidal turbine would be more interested in like Asian countries, Japan, things like that, where they have more of a tidal turbine environment. So 40-year jobs created. That's basically when a person is employed for 40 consecutive years. They think that there's going to be this many created for 40 years, which is pretty awesome. I hope this is the case because I'm hoping that I'll still be allowed to see this, but I really think this is something that we can do. So, a summary of the solar technology. The future of solar energy is upon us, so are you going to be ahead of the curve? It is an inexhaustible fuel source, which we saw that big yellow dot on that chart, that in the end would impact our environment smaller than all the other ways we retrieve energy. It is also much cheaper than it was 4 decades ago, from $100 to $3.41, and is getting lower as newer technologies are founded in order to make the process easier and parts made cheaper to go solar. Yet still 1/3 of our resources comes from petroleum, not solar. Experts believe this will change in the near future, as the 2050 chart in the previous page projects. Should we focus on using solar and saving our environment, or keep going at the rate with fossil fuels and try to find our future planet? Thank you guys so much for listening to us, and we hope you enjoyed our presentation. Thanks.